Charging algorithm. There are three types of charging algorithm. We have the pulse width modulation, the PWM charging algorithm, constant voltage charging algorithm, and maximum power point tracking. So in pulse width modulation charging algorithm, it's avoid overcharging the batteries. The current is tapped if the battery is close to full charge. So means that when the battery is close to full charge, the charging is stopped. The charge controller uses high frequency solid state switch. Yeah, there are transistors that they switch on and off wherever they want to operate. Now, in constant voltage charging algorithm, current from the PV is tapped when the battery is close to being fully charged. Also, it behaves the same way, but the controller uses non-pulse width modulation method. Now, in maximum power point tracking, we call it the MPPT control and DC-DC converter. They dynamically adjust the operating point of a PV array towards its maximum power point to improve the battery charging performance. So it allows the system to charge at a maximum power of the array. We have charge controller types and how also their charging algorithm goes. So in charge controller types, we have shunt type and series type. But we also have the MPPT, the maximum power point tracking that we are going to discuss. So the characteristic of shunt type is that they are on-off charging algorithms, means that they go on and off, on, off. That's how they do the charging. Then we have in the same, it has a pulse width modulation charging algorithm and a constant voltage charging algorithm. So it has the three algorithm styles. Then on the series type, also it has the same, but it has a maximum power point tracking with it. So with maximum power point tracking, the MPPT, I said before, it operates the PV array at maximum. So you can see this one is the maximum and this one is the minimum. So it allows the charging at this particular area. So you find that the system will always charge at the maximum power of the array. It can also improve the array energy utilization and permit the uses of more efficient high voltage array with low battery system voltage. So we have an inverter. Inverter is a very important component within the solar system. So the key function of an inverter is to convert direct DC power into alternating current. We call it the AC power. So as you can see in the diagram here, this one is the DC positive and also we have the DC negative part of it. So from here, it will change it to an alternating current, means that we'll be having what we call a cycle that goes up to the maximum positive side, comes to 0, and goes back to 0. So that one we call and AC, an alternating current, because it is alternating between the, the positive and the negative. There is advantage of AC in a PV system. So one such advantage is that the AC voltage is not lost much in the cables than the DC. When you have a DC, you will have high losses with DC, but with AC, you are going to have less losses. And also, we don't have more of the DC losses, the DC loads. Most of the loads we have, they are already in AC. So AC will serve you better than DC. So in the previous clip, I explained for you that we are going to classify the types of inverters according to the quality of waves. But also we can also check the type based on the application of the inverter. Where are you going to use the inverter? So based on the type of wave quality, we have the sine wave and modified sine wave. But sine wave is always the best that we are looking for because most of our equipments are using the sine wave. So based on application of the inverter, we have the grid direct inverter without battery. Means that you just harvest the sun, then you invert and use it direct. So as we continue, we are going to also discuss some of these based on the application. We have the battery-based inverter. This one has to use the batteries. They can't work without the battery. Without the battery, they won't switch on. So we have grid-connected inverters. This we collect power from the sun, then direct it to the inverter, then direct it to the grid so that we are able to balance the two. Then we have standalone inverter. These ones are off-grid inverters. Means that you don't use grid on them, but also you can use batteries or you cannot use batteries on them. So we are going to discuss more on this as we continue with these subjects.